Mrs. Peachy here, Unit 5, Spontaneity Reaction. Please look at these 3 laws of thermodynamics. Processes that are spontaneous in one direction are not spontaneous in the other direction. Another way of saying that is non-spontaneous. Remember, spontaneous does not mean rapid. Exothermic reaction of formation are negative. We learned that in the last unit, endothermic. So this is enthalpy stuff, delta H. Okay. If we take kinetics and thermodynamics, we can describe a reaction. Enthalpy and spontaneity. A spontaneous change involves going to a lower energy state. Endothermic and exothermic reactions can both be spontaneous. Spontaneous changes often occur for combustion reactions. I expect that you know combustion reaction for this course is a hydrocarbon plus an oxygen yielding carbon dioxide and water. A neutralization reaction, which is an acid plus a base forming a salt and a water. Melting, going from a solid to a liquid. And dissolving, going from a solid to an aqueous. Here's some examples of specific combustion, neutralization, melting, and dissolving. So we're going to look at entropy now. Entropy, notice that is different than enthalpy. S is entropy. H is enthalpy. Units of entropy are joules per mole Kelvin versus enthalpy, delta H, was kilojoules per mole. Entropy is the measure of disorder. The higher degree of disorder, the greater the entropy. I like to put this relationship down just to emphasize that relationship. Since we'll move toward the state with the most possible range of the highest probability of existing. So they're going to go to what's easy, normal, probable to exist. All right, so this is the first thing you want to write down on your green cards. And that would be this formula. Delta S, or the change in entropy, is the final entropy minus the initial entropy. I just want to remind you that when you see this delta or this triangle, it's always final minus initial for anything I would give you. If the change in entropy is greater than 0 or entropy is positive, then the disorder is increasing. I like to say the system is becoming more random. If delta S is less than 0 or delta S is negative, the value of delta S is negative, then the system is becoming more organized. Okay. When delta S is greater than 0, it's thermodynamically favorable, but disorder can be reduced by energy input. We'll talk about that and see that in the video shortly. Entropy changes for physical phase changes. Notice that the entropy change is less for a solid than it is for a liquid than it is for a gas. For freezing, solid to liquid molecules are more disordered, so delta S is negative. Think about as an ice cube goes from solid to a liquid to a gaseous phase, the particles, as they absorb heat energy, are speeding up and spreading out. Are speeding up and spreading out. So becoming more disordered. So here are some things that you need to think about. S increases as volume increases. So entropy increases as volume increases, as particles' mobility increases. That's what we just talked about, solid to a liquid to a gas. As temperature increases, as particles dissolve, and as moles of gas increases. I like to say another way of thinking of this is, what do I mean by moles of gas increases? That means when I go from the reactant side of an equation to the product side of an equation, there's more moles of gas as products than there are moles of gas as reactants. So here's some specific examples. We have basically gases go into a solid, so that's becoming more ordered. Okay, so delta S is negative. I have 2 moles of gas on this side right here of the reaction versus 3 moles of gas on this side. So delta S is positive, or it's becoming more random. In example 3, no clear change in state. I have 1 mole of gas going to 2 moles of gas. Remember, this number out in front tells us how many moles something has. So delta S is positive because there's more moles of gas as products. And then here we have an aqueous going to a solid. This is an example of a precipitation reaction. So delta S is negative. It's becoming more organized, less random. So if you could add this to your card, please. You should have a green card. If you don't have a green card, then you definitely want to get this written down somewhere on an index card or something. Just sort of an overall thing. We'll talk about what G is here shortly, but this does go through all the different pieces as it goes from organized to random. I really like to think about this side of the this side of the arrow, and then just know everything on this side is opposite. The only thing that's not as clear that's opposite is forming a precipitate versus dissolving is not quite, it's not like the words are opposite, like you would go from a solid to a liquid to a gas. Over here, you're going from a gas to a liquid to a solid. So just understand that forming a precipitate means it's aqueous solutions going to a solid, and the opposite is dissolving, solid going to aqueous. Okay, example 1 from our notes. Which of the following involves an increase in the entropy? We're also going to answer, or what is the sign of entropy, and then is it spontaneous or non-spontaneous? So we got melting of a solid, sublimation, freezing, mixing, separation, and boiling. You're going to need to figure out, first of all, if you can, is there a clear change in state? So that's what we're going to do first. So here we said, yeah, melting goes from a solid to a liquid. You should know, and if you don't, you need to know. Sublimation goes from a solid to a gas. Freezing is a liquid to a solid. Mixing, separation, those aren't states of matter, changes in matter, pardon me. And boiling goes from a liquid to a gas. Next, you're going to decide then if it is more ordered or more random. So here we know that going from a solid to a liquid is more random, solid to a gas more random, solid to a liquid more organized. Mixing up something makes it more random, separating something makes it more organized, and boiling makes it more random. So now once we know that increase in entropy is the tendency to go to more random states. So we have increase in entropy here, increase in entropy because it's more organized, decrease in entropy because it's more random, increase, so on and so forth. More organized, decreased in entropy, more random, increase in entropy. Now, if we know it's an increase in entropy, we know we can figure out the sign for delta S, or what we'd expect the sign to be, or predict what the sign would be. So we have increase positive, more random positive, more ordered negative delta S, more random positive delta S, and so on. Hopefully you get the idea. And then we can also talk about whether it's spontaneous or non-spontaneous at standard conditions. So if it is increasing in entropy, we consider it spontaneous. So spontaneous, and then increase, spontaneous, decrease in entropy, non-spontaneous, or positive S is spontaneous, negative S is non-spontaneous, and so on. So I could give you examples like these, or you could be given, I should say, examples like these, and then you could be asked to go through any of these or all of these. All right, here's example 2. We're going to predict the sign. We're actually going to do all those things that we just did a moment ago, just because I could ask you about any of those pieces. You kind of want to look at these reactions and decide, is there a clear change in state? And then if not, then you would probably count moles of gas on reactant versus product side. So here I've done that. I said, yeah, this is solid and a gas, solid. Okay, so let me look at moles of gas. Half a mole of gas on this side and 0. Here we have all gases. So we have 4 moles. Why? 1 plus 3, 4 moles going to 2 moles of gas. Here we have a solid going to aqueous. So we can write solid to aqueous. Remember, that is a dissolving. On D, we have solid to a liquid. Very clear change in state. And E, we have no clear change in state. Pardon me. So I'm going to look for moles of gas. We have no gases on this side. This wouldn't count. And 1 mole of gas on that side. On F, we have all moles of gas. So we have 2. Oops, this should be a 3. Let me fix that, please. 3 moles of gas on this side. 2 plus 1 is 3 plus versus 2 moles of gas on this side. So now that we can do that, we can go and kind of think about what we just wrote on our card and how that will work. So let's go back to the top and we'll go to the next slide. So more organized, okay? More organized. Remember, for it to be more random, I have to have products winning for the moles of gas race, right? So solid going to aqueous we know is more random. Solid to a liquid is more random. More moles of gas is products, so more random. Got to fix this number again. That'll be wrong on all these slides, but I'll fix it as we go here. And then I have more organized because products don't win. Once we establish that, then we can kind of use our definition of more random or organized to figure out sign, increase, decrease, and then spontaneous or non-spontaneous. So here we have negative delta S, negative because it's more organized, positive because it's more random, positive delta S or positive change in entropy because it's more random, positive change in entropy because it's more random, and that last one is a negative change in entropy because it's more organized. We could also be asked to look at increasing or decreasing. The red means increasing or decreasing entropy. If it's more organized, then entropy is decreasing. If it's more random, then entropy is increasing. So you can look through these. Again, I have to fix all these. Apologize, I cut and pasted poorly. And then we could also likewise be asked about spontaneous or non-spontaneous. If it's more organized, non-spontaneous, more random, spontaneous. So again, I could ask you about the gray, this section. I could ask you about the sign of entropy. You could be asking a question about increasing or decreasing entropy, or you could be asked about whether something is spontaneous or non-spontaneous based on entropy. All right, so your first homework assignment is spontaneity and entropy. Should be a worksheet. You're going to use your textbook. I copied the questions out of the back of your textbook, and I gave you a piece of paper with those on there all stapled together. And you also should have an assignment that has it looks like a bunch of boxes with numbers. So you're going to do 1 through 10 for all of those. Okay, let me explain a little further. I have now opened some other files to show you. So you should have gotten a copy of the problems. If you didn't, the sub should have them or get them from me. But here is 1, 2, 3, and 4. You could just use the screen if you can read this. And here is 5 through 10. What I want you to notice is that on 1, it's not a multiple choice. These are not multiple choice. These are which of the following processes are spontaneous. You're going to list your A, B, C, and D and tell me if it's spontaneous or not non-spontaneous. So you should have a copy of this. You should also have a copy of this. So this is the homework. It tells you which numbers to do and which letters. Okay, so pay attention. It just says A through C for 9. So you can go A, B, C, D here, and then you can write, after you go back and look at the book, spontaneous or non-spontaneous, and so on, whatever the question might ask. Hope that makes sense. Wanted to make sure you understood. So this is what the homework sheet looks like for the first homework. You should have a copy from this. Get it from me or from the sub. All right. So second half